Alright, in this video we're going to look at question 8 from homework 3. So here you've been asked to calculate the mean power usage for each year. So essentially you've been given a ton of furnace data, and you've been told that the furnace may or may not have been diverging in its performance. Maybe it's no longer as insulating as it used to be. And your job was to make a function that, given a data directory, so where the data lives, as an argument, you can completely map out how each year has behaved on a mean basis. Okay, so how do we do this? So I've got this little function we're going to be working with here, where we take in the data directory. So that's this furnace data / data, and let's go ahead and look at what that might look like. So here in homework 3 we have our directory, and you have furnace data / data, and in here lives a bunch of text files. And one of these text files, if we open it up, looks like this. It's just got numbers. Now what do these numbers represent? We can go back to the homework and we can see they represent one of these furnace runs. Okay. So what we need to do first is we need to get all of the files from this directory. So I'm going to go ahead and make a variable named files, and to it I'm going to assign a list associated with os.listdir. So listdir means list directory, and we'll give it the data directory. So let's go ahead and, since this is defined, we can go ahead and run this line here. Data directory is defined here, so let's just run the line, and we get files as a list with all of these furnace runs in them. So these are just the names of the text files. So the next thing we're going to do is we're going to say, okay, this problem statement, we are going to need to know the yearly power usage as a dictionary. So I'm going to make an empty dictionary, and as I loop through all the different years, I'm going to assign that year as the key with its mean power usage as the value. And the next thing I know I want to use is the years. I'm going to make a range from 1990 to 2019. So here what I have is how many years this data went through. And again, how do I know that? Well, looks like I closed it. Let's go to the File Explorer. Well, that's not what I expected. Show in external. We broke it. Homework 3. It goes from 1990, and I can inspect it and see it goes up to 2018, 11/27. So if I do a range from 1990 to 2019, this is the end value. It's not included, so it's going to go up to 2018. But here up to 2019, I guess, how do we say this? It's going to go up to 2018, and it's bounded by 2019. So if there's a number line, again, it's like a number line where we have these square brackets meaning included, and then the parenthesis meaning not including the endpoint. So that's what this range looks like if we were to think of it as a number line. Wow, sorry for the tangent. Okay, so what I'm going to do is I'm going to say for year in years. So for every year we have in this range from 1990 to 2019. Well, let's go ahead and store our yearly run info. So this is where we're going to average across, or this is where we're going to hold our average. So that's going to be mp.zeros. So essentially make an empty numpy array. What does this look like? Well, I ran that line using F9. It's an array with nothing in it. Great. Also, the data type is a float64. Fun. Okay, so for file in files, so for each year, for every file, we're going to get the file path, and we're going to set it equal to our data directory plus the file. Okay. Now there's something we want to do first. Before we start reading things in, let's go ahead and just say yearly run. Nope, let's back up. Excuse me. So for year in years, we're going to have year info as an empty array. We're just going to store stuff in that when the year is true. So we're going to say next if the string for our year, let's say 1990, is in that file, now we're going to do stuff. So if I run this here, oh, it's going to get an error. Run this here. Year is not defined. Define years. There we go. Year is 2018. So then I'm going to ask if year is in file. Well, for file and files, if string year is in file, then do stuff. Else, continue. So now we can, what is do stuff? Well, for a starter, let's go ahead and print the file. In fact, we'll print the year and the file. So let's go ahead and run this and see what happens. So now we get the year and the file associated with it. So we want to make sure that 2018's match. 17, 17, 16, 16. Good. So now in this if loop, that means we have the correct file for the year we're in. So now I'll say file path is equal to my data directory, because we need to be able to access the file, plus the file's actual location. So if we run this, we reach into furnace data, we reach into data, and this part grabs the actual file. So our file path looks like this. Furnace data, data, the file we're interested in. Now using that path, what I'm going to do is I'm going to say I have file info, which is equal to np.load text of my file path. Now load text works here not because it's a text file per se, but because it's a text file organized in the way, like organized with numbers in a column. Okay, so we're going to get file info as that load text. Now here's what I'm going to do. I'm going to say yearly run info is np is a concatenation of the year I'm on, which is yearly run info, as well as my file info. So what I'm doing is as the year progresses, or as I go through more files for that year, I keep getting more and more information about the runs in that year. So let's go ahead and look at how this one looks. And again, this is not necessarily an optimal solution. Oh, yearly run, year run info. There we go. Let's go ahead and look at what we have here. So year run info, it's going through all the loops. And here we go. This is 1 year where we can see all the values associated with that run. So we have 2,300 values associated with 1 year's run, like 1 year's worth of runs. So what did file info look like? File info, let's find it over here, has 47 data points in it. So that means for each year we had 47 data points in each file times however many files there were. Okay, so now as a last step, what we needed to do was for each year, yearly power usage, we need to say for that year, what was the mean power usage? Well, in our case, we have all of the runs concatenated together. In fact, I think we can do something crazy here. I'm going to plot it just to visualize it. plt.plot range length. So I'm going to generate just numbers on the line. Range length year run info. So I'm saying give me numbers from 0 to the length of year run info and plot year run info against that. In this case, I'm going to say give me x's, don't draw lines. And this is what we get. Huh, seems reasonable to me. Let's go ahead and plot file info and see what that looks like. So file info is one of those runs. So if we concatenate all the runs together, it kind of looks messy, but I think we did that right. My sanity check says that's probably okay. All right. So what we're going to say is yearly run info has all of the runs. So if we want this to be on a kilowatt hour basis, and the furnace runs for 8 hours, so we're given it in watts. I believe it says that in the previous question, in watts. We need kilowatts, so to get from watts to kilowatts, we can simply say, well, yearly run info in kilowatts is equal to yearly run info divided by 1,000. And then let's go ahead and make it on the hour kilowatt hours by multiplying by the 8 hours it runs for. Okay, so this is yearly run info kilowatts. Let's go say kilowatt hour. And so in here we have an array. Let's go to Variable Explorer, yearly run info kilowatt hour. Oops, excuse me. Okay. So these are all the runs in kilowatt hours, or all of the data points we measured across the entire year. So then finally, I'm just going to grab this and take the mean. Let's go ahead and get rid of that else. I don't think we need it. Okay. Now let's go ahead and run this and see what we get. Did we do anything wrong here? So far looks okay. Undefined name, yearly power usage. There we go. Okay. So now it's going to run for a little while. Okay, it's finished. Let's look at yearly power usage. So it's a dictionary where we have the year and the power usage. The year and the power usage. Excellent. Now, your numbers may not match mine. I'm not sure. Might be very close but slightly different. Don't really worry about it. What's important is that you figured out how to, whatever way you did it, how to get all of the information for that year, convert it to the proper units, and save a dictionary with those units included. So let's go ahead and get rid of this plot, and let's just run that. It says Q8 is correct. Excellent. So we'll call that for this video. Hopefully that workflow, you sort of understood what I was doing there. One last time, if you want to hang around, I'll explain this really quick. What I did is, first I listed off all the files that I knew I wanted to be working with. Second, I made an empty dictionary where I knew I was going to be saving information. And what I was going to be saving was going to be the year as the key and the mean kilowatt hours for that year as the value. Well, I then needed to find the years I want to look through. And for each of those years, we're going to keep track of that year's run information. So all of the data points for that year are going to be appended to this array. And so for each file in all of my files, if that file matches the year I'm in, go ahead and point to the file, load up the file, and add that file to this array that's keeping track of all of the data points associated with the year I'm in. Next, once you have all of those data points, convert them to kilowatts, and then convert them to kilowatt hours. We run for 8 hours a day. And then finally, for the year, in kilowatt hours, take the mean across all data points. And that'll get you the yearly power usage. And again, I'm worried about how you approach this. You think I have data to work with. How can I read it in? What sort of looping can I do to make this quick? Don't care if your answers are perfectly right. They might not match mine because I used a random seed to generate these values, and your random seed might be different because I'm not sure if I sent out the exact same data. So good luck.